Hey guys, welcome to Puddle Math, and in this video I'm going to be talking about a new way to factor quadratic equations where there's a coefficient in front of the x squared term. An important disclaimer is that this method is slower than the quadratic formula. If you can't figure it out just by looking at it in a timed setting, then just go with the quadratic formula and solve the problem and don't waste your time with this. However, even though it takes more time, I think it's a method that should be explored because the more ways you know how to do something, the better you understand that concept. So hopefully this method is something you'll at least consider as a theoretical idea, even if you would never use it practically.
So the first problem I'd like to look at is simple one that we already know the answer to, which is 2x squared plus 5x plus 2. And we already know that this is equal to x plus 2 times 2x plus 1. An important thing to note about this is that it's not helpful at all if the coefficient here is 1. Also, what this method does is it simplifies this to a point where we're factoring an equation with a coefficient of 1 that's easier to factor than this is. The first thing we're going to do is consider the general form ax plus b times cx plus d. And so when we expand that, we get ac x squared plus ad plus bc x plus bd. And so now we can write three equations. And so we can say ac is equal to 2, AD plus BC is equal to 5, and BD is equal to 2. And so what we want to do to solve this is we want to come up with expressions for AD and BC, because those are the two combinations we don't have here. And so the way we're going to do that is by finding AD in terms of B and C and then substituting it in here and then solving that equation. So A is going to be 2 over C, and D is going to equal 2 over B. And so AD is going to equal 4 over BC. And so then plugging that in gives us 4 over BC plus BC equals 5. Multiplying both sides of the equation by 5 gives us 4 plus BC squared equals 5BC. And so we have BC squared minus 5BC plus 4 equals 0. And so then we can factor this, and we see that BC minus 1 times BC minus 4 equals 0. So we know BC equals 1 or BC equals 4. Now BC plus AD is 5, so if BC equals 1, then AD has to equal 4. And if BC equals 4, AD has to equal 1. It does not matter which one of these sets we choose, but I'm going to choose this one just because I think it works out a little neater. But it really doesn't matter which of these sets you pick. They both work. And so what we're going to do is figure out the values of A, B, C, and D so that we can fill in this here and have our solution. There's only one possible solution for A and D. A has to equal 1 and D has to equal 1. Otherwise, neither of those can be integers. And then B and C has 4 possible arrangements. B could equal 1, B could equal 2, or B could equal 4. And then that corresponds with C values of 4, 2, and 1. And so now we're going to go back to our values of AC and BD. And we say, well, AC has to equal 2. So if A definitely equals 1, the only possible one of these that could work is C equals 2. So it has to be this one. So these have to be our values for our solution. And so we say x plus 2 times 2x plus 1 has to be the answer to this problem. And that's what we already knew the answer was. So now we're going to consider a more complicated problem that's harder to solve by inspection, 6x squared plus 37x plus 45. And once again, we're working with the general form a c x squared plus ad plus bc x plus bd, which we know will factor to ax plus b times cx plus d, which is the form we eventually want to get this to. And so we know AC equals 6, AD plus BC equals 37, and BD equals 45. Again, we're going to solve for A and D, getting A equals 6 over C and D equals 45 over B. Multiplying those together using the multiplicative property of equality gives us 270 over BC. And so, substituting into this equation, once again we're stuck with having to factor a quadratic equation. However, this one's much easier to factor than this one because it doesn't have any coefficient that's not 1 on the term that's being squared. And so BC minus 10 times BC minus 27 equals 0. And so we know either BC equals 10 or BC equals 27, and then AD either equals 27 or AD equals 10 because AD and BC have to add to 37. Once again, it doesn't matter which one we pick, so we'll just choose the first one. We'll say BC equals 10 and AD equals 27. So we'll write that here. So now we're going to write out all the possible values for B, and we're going to pair them with all the possible values that C would have when B takes those values. And then we're going to do the same thing for A. A could be 1, 3, 9, or 27. And so D could be 27, 9, 3, or 1. And we're going to start by using AC equals 6 and see if that'll narrow us down to a solution. And so, knowing that AC is 6, we're going to look, see if there's anything that A equals 1 could be multiplied by to get 6. The only thing A can be multiplied by to get 6 is 6, but there are no values of 6 in the C column, so this can't be a solution. 3 can be multiplied by 2 to get 6, and so there is a C equals 2 option, so that could be a possible pair of solutions. 9 and 27, the only possible solutions for C would be fractions, and this theorem deals with only integers solutions, so these two can't be solutions. So without having to consider B, D equals 45, we already know that A equals 3, D equals 9, B equals 5, and C equals 2. And so that gives us our solution of 3x plus 5 times 2x plus 9. And if we factor this out, just to double check, we get 6x squared plus 10x plus 27x plus 45, which is 6x squared plus 37x plus 45. So that is correct. So thank you for watching. I hope you enjoyed this video. And in the next video, I will be walking through a proof of this theorem that proves that it works.